Right, November 16th. Now we are here, Istanbul. Devconnect. I don't want to say Devconnect. But it's quite an experience, isn't it? I've been Matt from Blockswap Labs. I've been joined by our colleague Vincent, Director of Engineering, and our former verification lead, Andrea. How do you guys think about the last few days in Devconnect?
Well, there's lots of exciting ideas floating around, for sure.
About what? In general, or something?
Yeah, there's two main topics. So there's two main topics. Obviously, restaking, but the other one is intense. And what's pretty clear is that the ideas around these two subjects are still being formed into something really concrete. So, you know, we've been meeting with people, grabbing groups of people, and just you know, getting down to the bottom of it. What do you think, Andreas?
Yeah, I agree. So I've been mostly working on the intent side, but it has been interesting to learn more about restaking and get some input from others as well on that, and yeah.
So
some new stuff.
We came to the town with the two very pressing new topics, right? Restaking and intents. There's some overlapping, but it's two different verticals that is very hard, but just like it's very things. A lot of people are thinking deeply about how we can take this forward. We also met a lot of interesting guys, like in last day and the day before, we had the two houses on intents and for the restaking. But I would love to know from Andrea, what was the surprise for the restaking? Because something that you did not much involved in the sense of the mechanism, but of course the security part you are, but the ideas the other people came in, like what's your thinking?
Right. So the main thing that I was surprised about is that there was no. I actually thought that when I came here that restaking was like. It was a well-known concept. Everybody knew what this meant, but it turned out that everybody had different ideas about what restaking was, and that was a bit of a surprise to me, because I thought that restaking was what the K2, what we were doing, right? And it's just much more than that.
So you gotta tell them how the elephant is actually.
Really, yeah.
It's like there's a lot of misnomers about like how the delegation, what is a delegation, what is a stake. Have you thought anything particularly very clearly out of sync, like people thought, oh, it's very obvious, but it's not very obvious, like staking back when they're restaking?
No, nothing in particular.
Nothing in particular.
No.
So, what do you think? Because the K2 was the baby, you know, it's been there for a while that we doing the research, but now it is coming to the testnet. How do you think that the people that we're talking and the integrations, they won't have an ideas as from an engineering perspective? How do you think this guys wanted to use this product in, I don't know, a zillion different ways? And
yeah, I mean, it's you know, for us, it's more than, you know, a combination of like more than 3 years of active research in the space. You know, delivering stakehouse protocols. So we are consensus layer experts, bringing consensus layer stake to the execution layer on Ethereum. So restaking was a natural progression from that. And to really answer your question is, you know, people have some very, very interesting use cases for restaking. You know, we've heard, you know, all kinds of really amazing ideas. We're, you know, at an event today, and, you know, next door we have like a roll-up as a service. There's going to be many applications that are going to be reused Ethereum security in a restaking application. So people really want to understand how, firstly, they can get access to the security, how much capacity there is, and then operationally they need to understand, or want to understand, how much input is required from their side, you know, to get this up and running. And ultimately, from our perspective, the less that a restaking application has to do, the better, so they can focus on their application. That's what all good platforms should do, is focus on abstracting away as much complexity as possible, so that you and your use case in your application can have the most input rather than excluding to it. So that is a process that will evolve over time. And we want to get it to the point where you can spin up your own middleware. You just inject your subjective slashing logic for the it'll offer the for the slashing application, and you're good to go.
Right.
So
on that point, we heard AVS and node delegation. How do you delegate the stake, right? How do you get there's a lot of clarity, right? Most of the times, people just think, oh, I get some ETH from existing validators. Oh, let me give it to a node runner. And then he will run a service and he gets slashed and my money is gone when it is coming out. But how is this restaking work from the K2 perspective? What is a staking? Because K2 is very different. It just have a staking pool model, which is very hard to do. It's still a very research topic. Like even for the single network, it's multiple networks. So how do you think that the key difference here is delivering security? Are we delivering security to a node or delivering security to network level? How does this restake actually work as a profile?
It's always nice to take a look at a consensus layer as a proof of stake system and similar systems in that respect, and how as a network the consensus layer is defining security, and it's defined at a global level.
Right.
All the security parameters are defined at a global level. A single node is not going to cause the corruption of the entire proof of stake network.
Then it's not decentralized network; it's a centralized network.
Right. Exactly. Yeah. Exactly. This is we're trying to move away from the single point of failure.
Yes.
Yes. This is why we have high replication factor, and we have lots of nodes really. Now.
So, hold it a bit. Like you're saying that shared security means, in a perspective from the network that is getting that shared security, it should be assessed at the network level.
Yeah.
Correct. What is slashable that is having a liveness problem or a corruption problem as a protocol violation,
right,
from a network perspective, not just like one actor I couldn't turn up my machine, is not going to have this kind of a direct impact. You never have any kind of transactions rewarded just because one of the node is offline.
Right,
or
correct.
Or one of the attestation has been missed in the consensus layer,
yeah,
right?
Correct.
So it doesn't really work like that way.
No, it doesn't. Failure is embraced.
Right.
Failure is really sort of embraced, and you just build in a high enough fault tolerance. You don't want for your restaking application to rely on a validator that Andreas is running for your entire operations to succeed. You want basically a pool of high quality validators that have been curated from the consensus layer. But on the consensus layer, at an individual validator level, anything can happen, right? Things happen on a node and reflected on one or more validators. We've unfortunately recently seen the joining and immediate exit of 100 validators on the Beacon chain, but that's a node level problem, attestation violation that reflects on 100 validators.
Right, it's a collision. It's a correlated. Like how many people are doing that at a network level, right?
Right.
Then only you will get the impact.
And this is why we have things like correlated penalty on the on the consensus layer. So at a validator level, you can in theory you can lose all of your slash. In practice, it doesn't really happen. Most of the time, the worst penalty that validators encounter is an offline penalty, which is pretty small. And when you get to 16 ETH. You will be asked to leave the consensus layer.
That's a good point. So we're talking about delivering slashing security. in Restaking Cloud perspective, from K2 as an application, it doesn't really deliver you stake security, but slashing security, like from ETH, staked ETH.
Right.
So you're not going to reuse the ETH and replicate the whole ETH as a staking for other network, right? But you deliver as a slashing protection. If there's a slashing happened, and so from a proof of stake or any decentralized network, at stake is not what is slashable at any given point of time. It will be always lesser, right?
You can't rely on what's staked anyway.
Right.
Because as we were discussing with correlator penalty, coordinated attack, by the time you receive the bag might be empty. So,
but also, like, it cannot go, all of that stake cannot be gone, because network resilience will come into action. You will not see that all of the ETH staked disappear. Like
no.
Then
no.
the proof of stake doesn't work, right?
Right, correct.
There's some temporal rules, like it self-adjusts.
Right.
The network will go down, and then you can do a lot of stuff, right?
Yeah, I mean, nobody would use the consensus. Nobody would, want to take on that level of risk, right? So, it's carefully managed, but it's managed, like you said, at the network level. It's a network level security. So what K2 is offering is it is offering state replication that understands the staked ETH and can offer ETH for restaking in order to serve the application of the slashing security.
Right. So it just goes to the slashing as an application now.
Correct. Yeah.
So that comes to you, because there's like this a partition linear interest rate model. How do you charge each network as a separate profile? Something that you involved. So how do you think, like, the escalations, like if a particular network, let's say 100 networks has been restaked, and particular network has some sort of abnormal activity, how do you calculate this when they are availing the security in the first place, right? They need to pay for it, the yield, the restaking part, like, the charge. The pool is taking care of the charge because the slashing is paid out instantly. Mm-hmm. So what is this model, the usage fee model that we have?
Right. So when I calculate this interest rate, it was based on utilization, and it was based on this slashing logic that we have. That we have currently two kinds of slashing events. That's liveness slashing events, and there's a corruption slashing event. So and the utilization. So going back to the utilization, that is based on how much of the total. How much of the liquidity is currently borrowed. So if in the beginning the utilization rate is increasing slowly, and at some point approximately, I think it's currently at when we reach 50%, the interest rate, the utilization part of the interest rate increases fast, and this is to incentivize new liquidity, and also
more people to stake with the pool.
Yes.
Because they see this interest rate is high, and then they can get it because the yield is coming.
Yes.
Okay.
Yes, that is one part, and then there's the other part is that there is this slashing logic, which if you want to allow for higher slash amounts, then the interest rate is also higher because there is more risk involved, because the slashing is actually the slashing affects the interest amount that is being accumulated, that is being paid when you actually take the.
So these are two different rates, but it just work in tandem, or it's just combined.
Right. So they are. That's why we call it a partition, because they're independent of each other.
Right.
So this is a restaking application. So the parameters that the restaking application chooses is going to affect how much. They pay upfront for their slashing security. Right?
Yes,
They're paying upfront for that, and so reporters can earn some money for reporting. Slashing events, and like you said, there are two kind of events: liveness and corruption. And each restaking application will have different definitions of that. Each they just inject those rules. They don't have to worry about
Let's put
anything
something
else.
in perspective.
Yeah,
like, what is that the restaking service? Let's say an Oracle.
Let's say, yeah, Oracle's a good example. Yeah.
So
yeah.
what is the liveness of an Oracle will be? The Oracle has to decide what is the liveness, right? It's
Right.
something like
Let's say it's pretty simple. You cannot access a price feed.
right.
That's a liveness issue.
Right.
You know, there is no price feed available.
What is a corruption issue will be?
Corruption would be supplying the wrong price for an asset, or there have been various examples of oracles that are returning. They have a minimum price
Right.
for an asset, but a minimum price of $2, but it goes below $2. Then what happens?
But this liveness also could be per asset base, right? And it could be network level, the network level liveness outage,
Right.
or some of the assets could have some liveness issues. The prices are not coming from certain markets.
Right.
So can you have that liveness within that liveness category, like different buckets?
It's fully programmable. The middleware that a restaking application needs to deploy injects that logic, and your logic that you inject needs to produce a severity score. So the severity score is a single calculation, ultimately, that the middleware will use to help reporters submit their slashing to the smart contract. But as you were saying with the parameters, if you're asking for a higher, if you're specifying when you are requesting the slashing security, if you're specifying that you're gonna have a higher ETH per corruption event parameter, that means that you're expecting, either when something happens, it's severe, or you're expecting it to happen, frequently, and if it does happen, you want to discourage it. So this is about keeping the validators in check. I mean, ultimately, so the restaking application is paying upfront for their slash security. So they're actually, there's no tokens moving here, right? But they're paying upfront for that security.
They're putting in an escrow.
They're putting, exactly. Yes, exactly. And it is dripped to the validators that are mentally delegated.
As it goes.
Exactly, as long as they do their job.
Can they withdraw? Terminate the thing. Like, it's not working. It's not worth it, and I don't want it. Like, it's not working for our system.
Yeah, I mean the system has a lot of fault tolerance, so you can terminate your slashing security if there is, we've solved the double stake problem and the nothing at stake, right? So nothing at stake is like you don't have the native delegation, you don't have the balance from consensus layer delegated, so you basically don't have any security, right? So
there's no staked ETH available to
reuse, right? So then you basically you're terminated. There's no restaking application. You can't run your restaking application.
Right,
so you can terminate penalty free. You can of course perform early termination. On the other side,
So that's the consent from the stake owner to say that you can. The balance is being replicated and it's being reused on the network. The consent is required, right? That's basically.
Oh, right. Yeah. That's correct. You need to, if any validator or proposer that is familiar with software like MEV Boost for proposer builder separation, they are, whether they know or not, they're signing validator registration messages. And these messages are basically proof of ownership of the management of that validator, and the BLS signature can be used inside of a smart contract, especially when Cancun comes. We have BLS precompiled, so we can actually verify at a contract level that you actually give your consent for your staked balance on the consensus layer to be represented on the execution layer, but not just obviously execution layer. We can offer restaking to any kind of rollup.
So coming back to the question first, the liveness and the corruption. So even if it is staked, the liveness is the price feed is not working. The corruption is like the given wrong price feed. There's two different slashing. This can not only for Oracle. It could be like you can RFQ systems for intents or something can be like providing a price for satisfying an intent. If they're not giving with the market rate, they could also be slashed. There's some sort of an overlap, you see coming. So on that point, I want to just quickly take a swift turn onto to the intents, because obviously restaking, there's a lot of things to talk about, Reporter and the ZK, but In intent, what did you see? That's the
What is an intent?
Yeah, what is an intent? You cannot use Google Flight.
Well, yeah. So that's I think that's a joke we have had here at the conference that intent is just like Google Flight. No.
No.
So yeah. What I have been working on is I have spent a lot of time on at least. Defining what an intent actually is, because we had this intent kernel that we wanted to implement. Ethereum can be thought of as we can think of this as a state machine,
Right.
that, where we have a state and then we have the EVM. In the EVM we have a state, and a transaction will bring us to a new state. So this is an example of a state machine.
This is particular to the Ethereum in the concept of EVM, right?
That's the concept. Yeah, that's the EVM.
Okay.
So that is a state machine. So then what we have done is we have defined this concept of an intent state machine, which is similar. It maps states. It has state transitions, but instead of transactions, the state transitions are called intents. And yeah, so this sounds awfully similar to Ethereum, but it's not quite, because the intents have a predefined ordering, which is not there for transactions.
Which means an intent is kind of a partial order. The ordering doesn't have to do. There's nothing to do with the block ordering, but it's just like how the intent. Like if I say something, are you going to execute my wish first or second? Things like that. The intent has to be satisfied first, right? It's like to
Yes.
reuse it. When you say the ordering, what is the perspective?
So let me give you an example of this. Say that the common intent that people always talk about is the swap intent, and so say that I have committed a swap intent.
Right.
I want to swap 1 ETH or 2,000 USDC. This is this now that the intent ordering is saying that now there will be many ways to execute my intent. One way to execute my intent will be to, if you have 2,000 USDC, you can transfer 2,000 USDC to me, and you will get my
As a
one.
P2P, like peer-to-peer, right? Yeah.
That is a way to execute my intent.
Yeah.
There's also other ways to execute the intent. For example, if Vince comes along and he has another intent, he wants to swap, you can combine our two intents and actually make it, so we get our swaps that we asked for, and you can make a profit at the same time.
Does the wins should come from Ethereum itself?
I mean, Vince would commit his intent to Ethereum.
Yeah, from Ethereum, it should be from Ethereum. Is it mandatory? Like, I have a balance of $2,000, 2,000 USDC in Ethereum, but Vince comes from Optimism or Polygon, right?
Sure, that is definitely that is absolutely supported by.
Wait a minute.
The incentive.
You're talking about his is on different chain, and you can compose.
Yes, that is one of the key the key properties of the. That is one of the key properties that I was thinking about when designing the intent state machine. That we wanted this cross-chain support. It needed to support like this cross-chain computations.
Okay, so liquidities can be composed with an intense path.
Yes. So one use case that we have for this is the Multichain ERC20 transfer, right? Where I can submit, where I can commit an intent to transfer 1,000 USDC to you on Optimism, for example.
Right.
And then you will be able to execute my intent on Optimism. My execute I have committed to Ethereum. You can execute that on Optimism and receive 1,000 USDC.
So I could hold multi-chain LPs now with this construction from maybe it's from Ethereum, maybe it's from another chain, but I could actually supply liquidity to many chains but still stay on Ethereum.
Can I issue a stablecoin, something like that, from Ethereum to all the other chains and wind down? Like people can just deposit there and then, like, it's not only swap, intents could be anything, right?
Yes.
I want to open a CDP like collateral disposition so I can mint the token, but the protocol is in Ethereum. Is it possible that you can do that action from...
I think this is a good point. So pretty much all of this discussion that you'll hear around intent will be dominated by trading.
Right,
you know?
right.
Trading and tokens and stuff. But, you know, at the fundamental kernel level, we're dealing with a state abstraction that can handle any EIP in existence. And so we can make this about much more than just ERC20 tokens. We can deal with NFTs in a cross-chain concept, multi-chain context.
And I can say I will only want to have that NFT if the price goes up to a certain level.
So, right, yeah, it depends how you want to define your intent, and
we are defining as a smart contract, like just express it.
Sure.
You don't really need any other language, right?
But so what the intent state machine, or when we have an implementation of the intent state machine called the intent kernel?
Yeah, it's a solidity, nothing else. You don't need to not know any other language, right?
So what you do with the intent kernel is that you define the users can themselves, if you want to have an intent that says that I want to get this NFT when it reaches a certain price, or you want to sell when it reaches a certain price, then you can define your intent state machine using the intent kernel, and you can have this on the Ethereum that supports this kind of trading.
So it's a Solidity library, right? It's the type Solidity library you're talking about.
Yeah, it is, and
so this is how we express the value. That's what you're saying.
Right. Exactly. So we got to think about more than. So it's basically extreme. It's very expressive, right? So there are various attempts at intents, and they are whatever the constraint is. But we have Turing completeness really here in this kernel, and execution can be performed outside of the chain in which the state exists without breaking the state. So we have this concept of the intent computer. We have this concept of a VEVM. That is how we're defining it, and it is a virtualized version of the EVM, which itself is a virtual machine.
So you can actually do multiple domain things in isolation. That means you can actually do the MEV builder, and then make the blocks and just give it to it, and the bundles will get executed. But it just goes back into different domains with this computer.
Right.
Exactly. And it's all just a pure math. There's no other assumptions or anything.
No, you have. The key thing is deterministic execution. There is once an intent is executed and completed, there is a deterministic path of execution. So and it enables new interesting applications. I mean, we were having a chat yesterday with somebody from another protocol, and they actually were trying to figure out how they can use intents to simplify operations, and it really the discussion was very interesting, wasn't it? It was it's trying to figure out how you form these intents and how you abstract away certain parts of your infrastructure, because the concern can be like you have to provide the path to them, and it's kind of like, well, actually, depending on how it's structured and how you give them a topic to listen to, if like you could have a swap topic, right, and maybe
the solvers will just listen to that and they will just do it.
Correct. Yeah. And it can be so rather than building your bots for specific protocols like Uniswap,
just broadcast.
Yeah, right, exactly. So you could be solving for Uniswap and other exchanges, right? You just all unify them under the same type, right? And they will just be able to figure out the in between part, right? Users, I mean, there's all kind of possibilities. Users actually have a desired outcome. They have an input, right? And it's like you can, it could be as simple as you use my token. You can do whatever you want with it as long as you give it back to me. Maybe you can bake in an expiration. There are, it's fully programmable. And on-chain, with on-chain credibility, right? This is not off-chain system or...
And it's multi-chain, like you can just do all this.
Yeah, what if it's one of Vitalik's concerns, right? Taken care of, right?
Yeah, this is very exciting. So, okay, let's come to like, just to wrap it up. what do you want to see that in the next few months? Because every time we go to this community events like in Denver, that we're in CC, we could have the dialogue. We see this kind of progression. What do you see the next time from a Restaking Cloud perspective? What do you see like in the next 3 to 4 months? Because we're opening the testnet and everything. What do you think? What do you love to see?
Well, I mean, yeah, there's going to be a lot of exciting things. We're going to obviously firstly see, new applications and use cases are coming out of the woodworks all the time. We want to see people using the product in the wild, injecting the rules, providing templates. And just making it and reducing operational costs. That's what I'd like to see. So, rollups have big operational costs. So do oracles. So do bridges, relaying chain information, and there are a lot of ETH validators sat idle. Not idle. They're working for the consensus layer, but consensus layer as an application is not very strenuous and it's not got huge computational requirements. So they have spare capacity, spare resources. People are imagining all kind of ways to reuse that. So let's do that, and let's give validators additional revenue streams. Because the consensus layer application, the more validators that are joining, unfortunately the reality is revenue's going down. So the current solution is to kind of like chase your tail, stake more to try and keep your level, and then you're ending up in the same position as you were with proof of work, right? More machines, right? Well, actually, for the same machine, let's offer those resources out to the restaking applications.
Right. So, Andrea, for you, we've been presenting the intents. Now you're opening it up to public with the templates and playground. What do you think from the discussions? Do you think what you will have to see?
You mean like for the next conference?
Yeah, Denver. Let's say Denver. What you would like to see?
Well, so one thing I would like to see is like as a community we come to some kind of consensus on what an intent actually is.
That's a very hard thing to do. Consensus is very hard.
Definitely is. I mean, we have a suggestion now for what it is, and I hope other people will.
You wrote a paper about it, right?
I wrote a paper about it that people can take a look at, and I would hope people would do that.
But now they can play with it too. Whatever that you said in the paper, it's not a theory anymore.
Yeah, so we have this already. We have the intent kernel, right?
Yeah.
So that people can. Well, it has not been released yet. So that's something also that I'm going to be working on in the meantime. But yeah, just to get back that I would like to see people reading it and yeah. I'm not saying that we have the final definition of intent, but it would be nice to get some feedback on it, and it would be nice to see people come with new ideas. Maybe I think we will come up with something. We will find the right definition at some point.
And you think the intent computer that you're talking to, all the existing EIPs from Essentials and other kind of people, it is all reusable, right?
Yeah, EIP, I think it's 7521.
Yeah.
So we want to be compatible with those EIPs for sure.
So this playground will be available. So let's see.
Yes. So we have this currently the intent kernel that we are building upon the intent types library we're calling it at the moment.
Types library. Okay.
Intent types library. Yes. So we have something that we can play with, and hopefully we will be production ready soon.
I think that's a good way to be. All right. So that's a wrap from Istanbul. Obviously, we have a lot of talks. Everything that we talked about here is being presented here with the details. A lot of updates in the coming days. But yeah, it's quite exciting days. A lot of good conversation, a lot of good interactions, a lot of good things going to come out of this. All right.
Okay, thank you.
Thank you, guys.
Right.
Bye.
Awesome. Thanks.
Bye. Bye.